Hello, and today I want to talk about LLM Wiki, make review on my version and show you how you can build from scratch. But first let's talk about what LLM Wiki is and how you can use it. This idea was introduced by Andrew Karpathy 2 months ago, and I found this LLM Wiki white paper. It's pretty concise, so I recommend everyone to read it at least once, and after positions it as a pattern for building your personal knowledge bases. Those of you who already work with AI know such concept as Retrieval augmented generation, and basically this is when your AI makes query to your sources, which are indexed in vector database, and based on these sources generates response for you. But this concept is completely different. Instead of querying every time our sources, we build incremental persistent wiki with which AI works afterwards. For many cases, it works way better than default Retrieval augmented generation because your LLM have more context about your sources and they structured in a specific way you define in Schema.md. Now let's scroll down a little. As we can see, author shows different examples of how you can use your own knowledge base or LLM wiki. For example, you can use it for your personal goals, doing research, structurizing your business workflow, or doing competitive analysis. And LLM Wiki follows these 3 layers of architecture. First one is raw sources folder, and this folder stores all of your information that you need to process, such as articles, papers, images, code, markdown, you get it. And second one is wiki. This directory is where LLM puts your structured informations and builds your knowledge base. And Schema.md file. In this file you define custom instructions for your wiki, write constraints for it, and example formats. You can do different operations with your custom created LLM wiki, but one of the most common is updating it with new information after you ingested new source file, querying or asking your LLM information about it, and running health checks on it to verify that it matches your structure defined in Schema.md. For indexing and logging, LLM Wiki uses 2 markdown files. First one is Index.md, which stores all of your wiki files, catalogs, entities, and links between your files, acting as one librarian. And second one is Log.md. Every time agentic AI works with your wiki, it creates logs, what it has done and changed, so you keep track of this. In addition to this, I recommend using Git version control system, so you can always roll back to the stable version you need. In addition to provided operations and querying your LLM wiki, you can use Obsidian application to navigate through your wiki and discovering different relations using Obsidian graph view. You can do a lot more with Obsidian than just querying questions about your wiki. Now, when we already know what LM Studio is, let's take a look at our folder structure layout. As we have already discussed, we have our raw folder where our source files go in unstructured format, our wiki directory with our different types and nodes processed by large language model, index file, and log file in markdown format. And third one of the most important files, is Schema.md file with our rules. As you can already see in our project tree, I have created example layout with file in raw folder and wiki with my custom types. Let's take a look at our Index.md example. Right here we can see YAML front matter for easier navigation and making links between files. Don't worry about its params for now. I'm going to explain every one of these when we take a look at our Schema.md. And after our YAML front matter goes example layout structure of our MD file. We have only one header of H1 type, some example description, delimiter, and headers of H2 type. with some example information about concepts I've been working on. And last one is LLM instruction, which is used to refer an LLM agent to Schema.md if it stumps upon this file. Now let's take a look at our Log.md, and this file is completely empty because this is fresh LLM Wiki example layout. Let's take a look at our Schema.md. First of all, goes description of this file with only one h1 header. Next goes definition of YAML front matter with custom constraint for LLM that every file must contain a valid YAML front matter block at the top. Below is literal valid example, and below this front matter we have the table with definitions of each field. For example, most of this field using string format, but tags and aliases uses array format. I prefer ID in timestamp format because most of the time LLMs can hallucinate or duplicate UIDs, so it's more reliable when using timestamps for ID. For title, we tell LLM to identically match single h1 heading of the document. For the type, it must pick one of the defined in the allowed node types below. For status, it can change different states of our node, for example, draft, active or archived. How much our LLM confident of this node matching our source file. For example, when our model is highly confident that this information is present in our sources, it puts confidence high level. If it have not find any information or low amount of it, it passes low tag. Next we have summary field, which is concise TLDR, which improves LLM retrieval quality. Next we have array of our text for creating different relations between nodes and improving retrieval quality too. Timestamps when was not created and modified in ISO 8601 format, basically same as ID format, but with different symbols, you get it. Array of our aliases to make different relations between nodes and improve retrieval. Next, I define naming conventions and folder structure of our nodes names. We use kebab style, which means all file names start with lowercase, and we define explicit folder hierarchy for our wiki, which we discussed earlier. Next goes allowed node types, and you can define whatever you want in these files. For example, I have defined concept for outlining specific concept of our wiki, entities when we need to see relations between people and concepts or nodes, sources, which is structured raw files with metadata and additional info, log file for LLM, index for our wiki, example for our nodes, and our node type, which is different from concepts and entities. Next goes text normalizations. For this we use lowercase only and hyphen separated values without spaces or duplicates, similar to kebab case. Next goes modified field enforcement. I set constraints for this field to be as mentioned earlier in ISO 8601 format, and it should be updated on every file modification. And next one, I define structural constraints and chunking when processing our raw and source folders. For this, I define only one single h1 types of header as discussed earlier, and headings of h2 and h3 types should be used frequently, but no text block or document chunk should exceed 512 tokens to ensure context window alignment. You can edit this value to whatever you want, but I want my node folders to be pretty concise and simple. Next, I tell to never split code blocks, tables or equations across chunks and always provide full ones. And nodes should be related together, ensuring conceptual overlap across topics, so it's easier for LLM to see connections. And specific constraint to not use HTML and only purge markdowns. Next we define our linking system review. It's pretty simple. We use wiki links for internal linking and block references for heading references. Every concept should at least have one uncommon link or be marked as orphan. Next I define rules for formatting source and preventing it from using any external link. Next we define rules for advanced LLM directories such as embedding titles, headers or chunks of content. And one of the last ones goes retrieval ranking for querying our wiki and agent restrictions. You can review or modify it as you want, but now let's take a look at the prompt for processing our raw files with our Schema.md. For this I have created two prompt templates. One of them is for GitHub Copilot and second one is general purpose. You can modify for your needs, for example for Claude code or codecs. Now let's take a look at our prompt for Copilot. For this I add workspace files to context window, asking it to retrieve specific formatting rules in Schema.md and current structure example in index file. Ask it to store history in Log.md file and ask it to batch process all documents in the raw folder to generate full wiki according to our Schema.md. For every raw file it should analyze its contents, generate new markdown file in the appropriate subdirectory, enforce specific YAML front matter and update index and log files. You will be able to take a look at general prompt and other files I presented today from my repository, links to which I provide in the description. Don't forget to put stars and let's move on. For automatic batch creation of directories and files, I created these three scripts, one for Windows on batch, Python script universal for any system, which uses simple layout, only two functions, two tuples and no complex dependencies, and shell script, which is as simple as batch. Now I'm going to show you how you can create your own LLM wiki from scratch based on example I showed you earlier. Let's start by creating a raw folder, paste and place our white paper in it. Before this video, I asked Google Gemini to generate simple white paper in PDF format about Google Anti-Gravity IDE, explaining what it is and how to use it. I'm going to use this file to show you how LLM Wiki processes raw files. Keep in mind that you can add more than one PDF or file, but I will use only one for simplicity. Now let's create our wiki folder and Schema.md file. After you have successfully created this core architecture of your LLM Wiki, paste files from example into your wiki folder. As you can see, now we have example layout for our wiki with index example and log file. Now copy your Schema.md rules into Schema.md file and using prompt I provided earlier, ask GitHub Copilot to process your sources files according to Schema.md documentation. For this case I'm using Claude Haiku 4.5 model, and as you can see it's already started processing our raw file. By default GitHub Copilot does not support PDF, so I had to copy paste content of PDF into TXT format. So apparently I found out that this exact Schema.md is not really good for processing small PDFs because it only creates one file, so I asked Gemini to generate some more example files with unstructured information. And now I'm going to use exact same prompt and see how it performs. As you can see, it created batch of different concepts related to raw files, and now it's going to update index and format these files. As you can see, now we can explore our wiki using Obsidian desktop application, and it created simple note about overall anti-gravity overview. In my case, I had to update my wiki 2 times because on the first try it generated nodes without relations, so I pointed out this specific rule in Schema.md and it generated connections between nodes. If we take a look at our Index.md, we can see catalog of our concepts and sources, and this way you can create custom LLM wikis from your source files using example layout I provided.